Spacey colors and color space.
I'm here to tell you about colors. So what could be so interesting about them? I feel like we got that solved a long time ago. We got blue, red, yellow, you know them all. But turns out there's actually some new stuff, interesting new stuff in CSS. And it's a wider color gamut, it's called. And the current state of the art is called P3 or display P3. The one we use when we use something like RGB is the smaller triangle in the middle. As you can see, the smaller, therefore worse. You don't get all of these exciting colors out here. But of course, given that this is a projector and also I'm streaming it through Zoom, you can definitely not see any P3 colors in this image, which is a problem for a demo. It was actually interesting. I also wanted to demo these colors. Yeah, I wanted to display them. And I tried to muck about with the Keynote. And Keynote does support P3 images at least. But they cannot, at least I could not figure out how to set the color gamut. So I was forced to do it in the browser here. Yes, all right. So this is probably some color functions or ways of describing colors that you've seen before. You got the weird old HTML color names, like goldenrod, and you got the hex codes. You got RGB, where you got the individual properties, red, green, and blue, and then you got some newer ones like, oh, I don't actually know if they're newer, but maybe a bit more interesting like HSL and HWB. HSL would be hue, saturation, and lightness, which is a nice way to describe colors, which is more in tune with how we perceive them as humans. There's also some new ones. And these ones are way more interesting because they do not start from the perspective of a computer and what is easy to represent in numbers. They actually start from some studies we did on our eyes, or human eyes. Turns out our eyes are definitely not linear in lots of has lots of weird edge cases and perceive some colors better than others. So building from that foundation, they build these new color formats based on the first one I'll bring up is LCH, light, chroma, and hue. And chroma you can think as the intensity of the color, lightness, and hue, I think you know what that means. Then you got OKLCH, which is a pretty okay version of LCH. It basically just corrects some weird edge cases that one had. So I'd say you can pretty much ignore LCH and LAB because the OK versions are slightly better. Yes, and I think OKLCH is a little bit easier to understand. If you wanted to represent the color, you could get it done just from mucking about with that, whereas the OKLab is a little more weird since it has an A-axis that goes from green to red and also a B-axis that goes from blue to yellow. You probably can't really figure that out in your head up front, but it is useful for other stuff. So they also come with some new color functions in that is, I think they are supported in all major browsers now. This is how they look. For older browsers, you probably still have to have a fallback color. I'll get into that later. You can also do it with this syntax, and I think this has been supported in Safari since 2016 when they made the first screen that supported it. And this is actually very easy to understand because here you just use the color function and you say, I want to work in the sRGB or the display P3 color space or any future color space. And you set the intensity of the different values. So 100% in sRGB is the maximum a color can be inside that space, whereas 100% in the display P3 is slightly bigger. So that's what I've done here in this comparison. You can absolutely not see any difference here, but oh, you can actually see it. So that's also a bit interesting because you should not be able to see that. And that is because, ideally you should not. That's because I have not defined a fallback. I just let the browser deal with it. And I think it does some, I don't know how it does it, but it's not perfect, at least when it collapses it into the supported color space for this screen. But anyways, it should be more visible here. I'll just bring it around so you can see it. Some more try and fill it. There's some more. Blue, slightly less visible, still definitely visible. Green, it's quite visible. Yellow, not so much, I think. Purple, pretty visible here. I think that's the most pronounced one. All right, let's see. Yes, another thing that is pretty nice with these. I don't know if you've ever tried to define a gradient in the normal sRGB color space you didn't even know you were using. And you get these kind of boring gray in the middle. It's very annoying. It does not look like the exciting gradients on marketing landing pages. And why is that? It's because our eyes are as they are, and it travels through a lot of gray. If you ever seen one of these color wheels, the gradient would travel through a lot of gray parts. And then you can get the sRGB linear. It's slightly better because you don't get a more evenly distributed gradient. Yes. And it's actually interesting because this one is definitely not linear as seen from the computer's perspective, but it is more linear for your eyes. Then you got LAB. Now it's so annoying to watch here, but on my screen anyways, the lab one, you get some purple here in the middle, and the OK lab, you get I think the most beautiful gradient here. They all are going from white to blue. So OKLAB, that was the one that was the weird axis, A and B axis, but turns out that one is really good for gradients. And then you got the LCH, which goes through a lot of purple, and the OKLCH, which goes through green. So that's also something you can decide when you choose a color gamut. All right.
Quick comment. So all of these are just saying white to blue.
Yes.
And the only change is the color gamut, color space. Right?
Yes.
So this is the same gradient, just the color space change. So that's why it's weird that the bottom one is also green, because from white to blue, you apparently that color space has green, because it's not the normal color we're used to seeing. It's some sort of three-dimensional color graph.
Yeah, these ones go through a numerical color space. Try and imagine that. All right, so there's actually more interesting stuff with regards to colors, but I won't go through the rest here since we are slightly constrained on time. But you can also mix colors now. So you can say I want 20% blue and 50% red. So then you'll get the resulting color, and you can do that with some really nice color functions. I think this has been possible with what's it called, SAS maybe before, but now it's supported natively in CSS. Super nice. Number 2 here is one that I'm actually most excited about. You can define some really good looking color palettes. We just say, okay, these are my 5 colors, full intensity, and then you just play with the lightness variable, lightness part of it. And if you did that in sRGB, they would definitely not look pretty, because different colors, when you just mathematically adjust the lightness value, it does not look good. At least it does not look uniform across colors. But if you use one of these newer ones, OKLCH, you will get like a perfectly looking color palette, and with maybe 10 lines of code if you have 10 colors. Yeah, super nice. What else? Yes, Figma recently added support for it, which is late. Sketch has had it for a long time, but it just has not really caught on before now. I don't know why it happened all of a sudden. You can use it now. There is if you use Tailwind, it is not, you can make it work, but I say, and that's I guess what we do, we're gonna wait a little bit, because Tailwind's next version, which is they call it Oxide, the new engine, it will support generating these fallbacks natively. So you just say what you want in the P3 space, and at compile time that will add a fallback. I think it's like add supports P3 color space, and then if not, then we'll render the other one. So that's pretty nice. Yes. How much time have I spent it all?
You actually have 10 minutes left.
Okay, then I will definitely take you to this one. So this is, if I had a million years to do my slides, I could have done this instead, but somebody else did. It's actually interesting. These are different colors, even though the screen does not support it. I guess that just means they are both worse than they are and how they should actually look. But it's interesting.
It might be the zoom compression that's recording your screen, seeing the difference, and then changing the colors.
It almost has to be. That's weird. It's very weird. But here you can see this is what would normally be a square, perfect square if you use one of the boring old ones. You have seen them with the color, you can pick a color in the square. But this is more how our eyes work at this color. So let's go to green here. And you would, if you stay within the sRGB color space, this is what you get. And up here, you can get some more interesting green. And I'd say it's quite striking. And maybe you should not overuse this for every, maybe don't make every color, every button this color. But for example, for a marketing landing page, it can look really incredible. And you also see that some colors has a bigger difference than others. Yeah, you also saw that before actually when I took you through the slides. Let's see, I could maybe also, what is it called? No, it's just an example of a pretty cool landing page that has free support. At least on my screen, these colors just look out of this world when you're used to seeing stuff in sRGB. Yeah, I don't know how yeah, obviously can't see that, but anyways, I think that's it for colors. Any questions?
Maybe just a comment.
Yes.
You mentioned it a couple of times regarding browser support.
Mm-hmm.
See, at least for Chrome, it's supported since March 7th this year.
Yeah.
So it's quite new. Yes. But 85% of all browsers support.
Yeah, and that's why it's good to have a fallback strategy.
The browser will do.
I actually don't know about old browsers that don't even know about it. I don't know. This.
How many devices and screens support showing, the cost?
You gotta look. I think most Apple products do now. I think all as for a long time actually.
92% of phones.
Yeah, phones definitely okay.
83% of desktop.
That's pretty good.
Most.
Yeah, that's nice. Of new.
Local.
In use.
It's a browser support, right? Because just because your browser
That's not the same. A screen has to support it. The actual hardware has to.
Old laptop.
Yeah, they definitely don't. So it is a nicety. You can definitely do without it. Say you get up if you use the gradient stuff, you still get to avoid all the gray parts of the boring gradients, even if you can show it in the full color spectrum.